Hi folks, this is Vishwas Narayan. I'm from Pioneer Bangalore chapter. I'm also a part of the session called as the Computer Architecture Club. So we actually have two communities combined together, and we will be hosting lot of such events like this. Trust me, Computer Architecture Club is something which is more unique and more touched because I always wanted to do something more towards the computer architecture, the hardware and the software of it. So that's where I really started off by getting some of the things where I really wanted to learn something new. So, hi, welcome, Sai Praveen, for this webinar on natural language processing, where it's basically we are approaching problem statements using the NLPs and different techniques and things like that. So, hopefully, you guys learn something new from the webinars that we'll be conducting over the course of time. And this is actually the pre-event for all the Pioneer Bengaluru and South India Summit that we are conducting. So I hope this series of sessions that we are doing gives a lot of insights to you. Ashish Sharma, what's up, guys? Cool, brother. We are all fine here. So over to you, Praveen. It's all about for you now.
Yeah. Thanks a lot, Viswa, for joining today and most of the people who joined here. And very good evening. Today, most of the session, I will be talking about NLP and the revolution as well, new concepts which are evolving in terms of NLP in the industry level. And as well, where we should look and what are the next approaches or the next future advancements which are in NLP and where we need to focus or and where exactly we stuck in terms of these areas. I will quickly go through the session and start it. Yeah.
You can share the screen now. Yeah.
Vishwa, is it visible?
Yes, it's visible. Yes, it is visible.
Yeah, thank you. So today, in terms of NLP, before going into NLP and all this stuff, I just want to show a quick understanding why we need this in terms of career growth in individual perspective level. So what exactly you will take away from the session and how exactly it will improve your growth and your in terms of your career, right? Before I just want to present the Gartner's analysis recently in February, which they showcased what exactly the industry is looking from the IT tech guys and where exactly we stand. For based on these applications, you can see so many distribution acquisition. What is you can see applications across a low code application platform which having so much of traction nowadays, and edge AI, which is becoming more and more crucial to implement AI applications in terms of which can be available to any actual devices and all those stuff. The yellow figure which you are seeing here now is where they confirm within 1 to 2 years this technology will be available in the market in the production environment. But when it comes to NLP, what the present situation is, you can see the transformer-based models at least take another very high, but it at least take another 3 to 6 years for the industry to actually use them in the applications. So why there is so much of gap between when you compare with computer vision and NLP, there is so much of gap, right? So I just want to make understand why there is a gap in between these two and where exactly the NLP researchers are focusing on to improve the present existing models, right? So this is where our key area will be based on transformer-based language models and the pros and cons and what are the tech pioneers who are evolving so much in this area and what are the other research options which are available for us to make sure to grow in our career, right? When we go to a quick side, I just want to give a small example of NLP, which was used by IBM, which is a debater where AI will debate with human and have a standpoint and make points clear Please just enjoy the video, and it's really good and very convincing.
In kind. IBM's newest artificial intelligence system took on experienced human debaters and won a live debate. Subsidizes space exploration like never seen in other times.
Praveen, there is no sound, it seems like. People are saying there is no sound.
Allow me to respond to some of my opponent's most recent claims.
Yeah. So have you seen the video, right? So basically, IBM created a debater, which AI debater, which will argue with human beings and make a standpoint with the reasoning structure. It's like the how the human being will understand any text and information and respond it back with what are the theories and how what exactly they understand from the topics, right? So before I mean, it's like AI is involving so much in terms of NLP and understanding the text, the way we respond, and the dialects of the linguistics and all those stuff. It's a very good and very impressive applications of NLP. And before going into the depths of NLP, we just need to have touch base what exactly NLP. Basically, NLP just deals with the text data. That's all. Like text can be in any format. It can be in an image. It can be in a normal text editor, any file, or we can have a blog or storage, or where we have we can say in financial data where we have some of invoices. Like that. So wherever text is involved, we can use NLP and reduce the time to analyze our text data, and where we can get more insights what exactly the text is referring to. And some of the these are basically the basic techniques which generally uses is lemmatization, word segmentation, backup words, word parsing. These are the basic common techniques which we use in terms of pre-processing the text, making it understand, make it available in terms of vector representation so machines can understand, right? So this is where this in this area of segmentation, the best industries which actually revolutionizing this total approach in this area are three startups. Basically, Explosion. Many of you are heard of Spacey. Spacey generally creates open source models for us to utilize, and Explosion is a startup which actually partnered with Spacey and providing a tool called Prodigy, which makes us to retrain the model in a very better way. There is some specific reason related to this Explosion Prodigy, because uh, most of the NLP models need a huge corpus of data. When I say huge corpus, it's really huge. So basically, whatever the data which we will get from any industry is very raw material. like raw. So to make it fine tune and make it in a better way and format it as per the model, it's a very labor task. It takes so much of time to label the data, to utilize it and other stuff. So to make it very simpler way, Explosion came up with an annotation tool called Prodigy. It has some price cost to use them, but as per the present industry, that is the best tool which we can use in our ML toolkit in terms of NLP related projects. Other than that, we already know Hugging Face basically provides open source transformer models, very huge, and very simple to use. We just need to download the Hugging Face and give the transform model, just call it and run it, just like that. So on John Snow Labs, these are very peculiar from other two, because Johnson Snow Labs basically works on Spark NLP. Since when I say NLP, it consists of it deals with very huge data. So the process to do computations on top of it, which makes which makes very complex, which makes time lagging, right? So to use the Spark and scalability in terms of speeding the processes and all, John Snow Labs is experimenting with Spark NLP, where they created a framework on top of Spark so that they can utilize the present day-to-day transformer technologies in Spark, so that it will the latency to process the program or to train the model will get reduced. It actually supports around 400 parallel instances at single time. It's really huge, and it's really very lovely to listen. And basically then we can come to the basics of NLP. What exactly NLP? Specific pre-trained models which are available as per in the market, with some related to an example like machine translations, or Google Translate, Azure Translate, what are translation engines which we can use, or language detection, which language you are using before doing the translation, sentiment analysis, whether it's positive or negative, text generation, text summarization, semantic parsing, like all this stuff, right? Basically, these are the application models which are available in the market. So we can utilize for a specific, for example, if you can say, I just want to know what is my brand value in the public, and in from the Facebook or the Twitter, what are the tweets. I just want to know just what is my brand value. Then whether my company having so many negative thoughts or any customer review on a specific product, then I should go with text summarization, and then understand the data, indexing the most of it, and then understand sentiments, whether they're liking the product or disliking the product, what are the main features which are affecting these decisions, right? And then text summarization comes into play in terms of if you're having a huge, if you have seen a mobile app where it consists of so many books, which it will say it summarizes the whole book in just 12 lines of paras. So instead of reading 400 lines of book, we can just know the summary and then understand it. So for a human to do all this stuff, it takes so much of time, right? So this is where NLP comes into play to reduce the time in an effective manner and utilize it for other purposes. And then the next emerging market will comes into conversational AI. When conversation has so many use cases related to customer service, or you can say chatbot specific to specific product, or internal employees where they can find the data, relevant information, like that. So these are the model specific, which are models available in the market. Then we can come to the applications, right? Technical applications like I said, virtual assistants, information retrieval from the structured data. I have so much of huge corpuses of data, but I need only specific parts of it to extract and save it in my databases for the early later analysis of top of it. So it comes information in smart search, Google search. We can say it a smart search, where exactly it use LLMs. When you write any query, we will go into that specifically. When you write any query, how exactly it retrieves the relevant information from the search, right? Like the semantic chatbots, these are the very broader area of NLP where the applications are used in the industry level, and there are some other applications as well, which are in still in research, which didn't came into the productionization level as of now. Then we can go through the roadmap, how exactly NLP actually started. Basics, like we can say, it started with a bag of words, and then it went into TF-ID of count vectors. From then we are creating a vector matrix, and then I'm passing to any model, whether it can be text classification or it can be clustering of the whole text, which is unorganized, or information retrieval specific to CRF. You can use CRF conditional functions to write a rule-based engines to extract information. Then we went into named entity extractions and all this stuff. So when we actually see how exactly NLP has started, it really started with just two in a very process, like when we understand humans with text and all, how machines can only understand numbers. So the best way to make machine to understand any text is convert all the words or numbers into a mathematical format. Then the vector will be used to fed into the models to understand what exactly the text is referring to, right? So in this process, right, there are so many problems. For example, we can say we have there are so many languages, right? Multilingual. Hindi, English, Japan, French, China. So each sector, each language has different dialects, different grammatical structures which we need to imbibe. When we generalize any application, we should look into all these areas of expertise, which language, whether it is having those dialects available, whether it is actually using them, like that. So it's a broader areas, and when we generalize NLP, these are some of the hardest problems which we will face, which we are facing, and most of them are solved, but there are some more which are still yet to be solved. And then the revolutionary of NLP actually started in 2017. Till 2017, it is very low pace, like very low pace. It's not like computer vision. Computer vision has so much fraction, and it improved a lot in the advancements, and the results are very amazing. In NLP, the actual paper which turn around total NLP process is actually attention is all you need, which is from Google AI in 2017, which exactly made changes in terms of how these vectors are created. How these vectors are created, how exactly the machines understand what we are saying, whether it's emotional intelligence or sentiment intelligence, or what exactly we are referring to, or like that. So this is the paper where had made industry turn around, and which most of the big companies, Google, Facebook, most of them actually looked into. This is a concept which we need to utilize in terms of NLP and improve the results. So today mostly I talk about, later we have fast AI, BET, and all this stuff. There's so many advancements, and lately in 2020, later we got GPT-3 as well. We'll talk about that as also. And then today I just make sure to go through what exactly this attention is all you need paper is explaining, how exactly changed the whole graphs. From here, I mean, the rest of the models uses a complex network layers, but the base model for all this is attention is all you need. Okay. Yeah, we can go into the representation, like when any sentence, if I say a text called hello review, right? When I tokenize it, what exactly I'm doing that we have 4 letters, and then I'm representing each word with a specific number. It's basically like, for example, in English, all the characters from A to Z will have a specific number. Whenever we're converting it into a bag of words or word to bag, what exactly do is the number of times each word is represented in this character, right? How many number of times a word has been represented. But basically what exactly it is missing is positional data. Positional data is actually required. Positional data is actually required. Why exactly it is needed is, for example, I can say uh, uh, Bob likes its dog a lot, right? When I say the meaning is Bob is a main noun which is saying that relating to this dog, he likes it a lot. When I change the setting, which a dog don't like pop, like when we change the location of any word, then but the word to vec or TF-IDF represents the same vector. For even though I jumble the words, the tokenization is created from word to vec or the tokenization created from TF-IDF are same because it don't take the positional position information from any of these sentences, which actually is really required. Later, then this is the main problem to on which was solved by attention is all you need application. So this is the way how exactly attention is all you need looks like. Tokenization embeddings here. Similarly, we are creating the word-to-vec applications here. Word-to-vec applications. On top of it, we are getting a positional encodings of each position. It is like on top of this vector, I'm getting another vector. I'm doing is sign a dot product and creating a matrix. And these matrix consists of position and as well as with the token embeddings, which actually make sure this information is carried forward to the model whichever I'm feeding it, right? Then we can go into what exactly the attention and adding other layers information, right? The position, then tokenization, and then information doing the dot product. Then we got the huge matrix which consists of the words which are already there and the positions, relative positions of the words in it. So this information carried to the next layer. The next layer will comes with uh, the next layer comes with attention is all you need. Basically, you can see QVK. QVK are the parameters which actually goes through here. Q is like query, which what exactly I am referring to, and V is the values and K is the keys. Right, based on these three factors, generally NLP will work. For example, in Google, I can just say, what is the top 10 NLP companies, right? When I say top NLP companies, that is my query. So my query is getting indexed and then searched through all the databases and then getting the relative information. Based on that, first it will do is it will create the relevant keys which are available in my query, and with the keys, it will attach to the value which value is representing these keys, and then it filter out with the query. Query is like a filter, so it will give me the relevant information rather than the other stuff. And basically, if you can see here, it's not just attention is on it, but it comes in a parallel way. What exactly it does is when I say hello, I love you, right? Simple example, right? It will at each parallel computation, it has 4 words, right? It works in a parallel manner, like hello will be my first, so whatever I'm seeing the context is related to hello, then it will refer to I, then it will refer the attention of the words will change for each cycle, and it runs in a parallel way. So since we have 4 words here, it will run a four instances, and in each instance one of the word will be the attention. So how exactly this word is mapped back to the other, how it is related to the other words in the sentence. This is how attention is like, we are specifically looking for this one, how this is relevant to the other topics, right? And then, so basically in the transformer, this comes, so this whole block comes as, not exactly this whole, this is a basic block of tension as all you need. Like that, we can have multiple layers of attention units and combining together to form a single layer, right? So basically now what we need is just only 3 steps, but we have the sentences, then we need their embeddings. After embeddings, we need the position of those embeddings with encoding, and then that vector should be passed to my first encoder block. Okay, this will be the overall journey of the encoding part of the transformers. Like if I said the parallel processing, right? Here you can see WQ, WK, and WV. WQ represents the words from the query, and keys, and WV will be from the value. Right? When I say value, is basically my information which I already have. Keys is what exactly it's like topics we are referring to, and query is what I asked for. So based on combining all these three, I will create a matrix which is attention. Then I pass it to the softmax layer, which actually creates the weights of my weights of the information, and then it will search for the relevant data from the databases. Initially, adding these function called position encoding made a revolutionary change in terms of NLP. Where earlier other techniques like packaboards or compact traces or POS, they don't have this information of position. Since we don't have the position information, we are only talking about one sentence at a time instead of a huge paragraph. How exactly the first paragraph referring to the second one, second, third. Now I have the position information, then I can refer. So this is where this topic is talked about, and then this is how it is exactly mapping back to that position, like that. So this information carrying the position of which the embeddings is the main key factor which made so much of revolution in NLP, and the models which we are seeing now are more accurate because of this specific change, right? And then we have that is only from the encoder part of it. Okay, when the embedding layers, multi-headed information is a parallel processing of each word will get attention at each time, and then we will go to the softmax function where we create the probability of which the output answer. Then we will have the decoding layer, right? The decoding layer will do the decodings related. There will be a masking on top of it. After the masking, they will again come back all these processes and decode the information what exactly the layer is showing here. And the main building blocks of NLPs nowadays is transformers, because the way it understands the language is like very peculiar, and it improved a lot of accuracy levels everywhere. And after transformers came into the play, what are the existing rules? They instead of having hundreds of layers of attention multi-headed attention layers, they thought that if we have around 2 trillion, 3 trillion, and more parameters to pass through as network models, and then understand the text and get the relevant information where it includes so much of infrastructure and the scalability of the data, like that. Once it is done, then the newest approaches which are relevant to 2021 market is basically GPT-3. And recently GPT-3 has partnered with Microsoft, where they provide the support where we can directly call and use GPT-3 in Power Apps from OpenFX functions, so that we can have the visibility of using GPT-3. But as of other than that, GPT-3 is not available for public, and we cannot actually use them since till they give us a permission, right? The later recently, just like 5 to 6 days back, Hugging Face actually given a open source model which is GPT Neo. Basically, they called it as cousin of GPT-3, which actually has a similar structure, which works as similar as GPT-3, but which has less parameters to fine tune. And then it comes where we can utilize the GPT-3 capabilities. Right. How we can use GPT-3 Neo? How we can use GPT-3 Neo is very simple. Like we can just download the torch transformers, where I'm just calling the GPT-3 Neo casual ML, and where I'm calling a Neo already pre-trained model, and my input I'm doing the tokenization on top of the input sentence, and then I'm asking the model give me the output loss, like that. So this is how we can directly use these models. And the best thing about NLP is so many models are open source. The reason because capturing a specific, for example, when we compare with computer vision, always when I look any object like car or any object like a football, or whether they're doing football and all, the object is always same, right? So it won't change. Whether the image, whatever we're calling it will be different. The image is always same, similar. But in terms of NLP, that's not the case. Each language has their own words. I can speak in Hindi, so I can refer any person in different language with the different tokens. To map back all these languages and make the machine understand the differences between language and train on top of it is very cumbersome, and it's really very hard to process these. So small companies cannot actually train the models to actually utilize them. So most of the Hugging Face or Spacey, they queue these open source models so that we can directly utilize them, which are already pre-trained with the huge corpuses. Later we can do the adjustments relative specific to our use cases, which is easier than we developing the models from the scratch, right? And next we go into what are the, and before going into these, I just want to come back. When we can see this structure, right? What exactly happened here is, I mean, basically these models are all called large language models. They're LLMs. When the most of the industries have given attention to LLM models to process them, they're very huge, very big models. We cannot process in normal systems. They need huge GPU support to train them. It takes so much of pre-processing of their from the raw data. It should have a specific format, and then only we can train them, right? So to maintain these applications in any individual usage, like if I want to create a sentiment analysis bot, how from the scratch, it is very difficult for me, because all these require, if I want to use GPT-2 resources there, it takes so much of my resources to install them. When the model which we can just download, GPT-2 will be around 2 GB if we download the actual image, actual model, right? So then there comes the edge computing, where they made things simple to make available in mobiles and other devices. Instead of using the actual model, they reduce it to 1/10 of the model, and then utilizing images. Still, that industry level is yet to come. But there are some challenges in terms of large language models. Some are when the companies actually train these models, right, the data itself is biased. Bias in terms of not exactly what we are trying to do, whatever the text we are training them, the data itself has a bias. They found recently, even Google, some of the employees, they got a notification related to these explainable concepts related to that, because when they understand the lambda, which was addressed by Google, when the model is, whenever we say doctor, the model is always referring to a masculine gender, and whenever we are asking about a nurse, it is referring to a feminine gender. So and the rationalities of the language and the regions of the data, all these complexities, right? Because when I'm training the huge corpus of data, most of the data is available in Wikipedia or Twitter or things. All the data which we talk generally in terms of these open source platforms are already a biased information, right? So how to clean up these models is the greatest problem for now, and that is where still the NLP researchers are working on to figure out this problem. Yeah. Then can go to next learning parameters. So since the most appropriate way to make understand this language model situation is like, to use these technologies, we need a proximate scope situation framework. When I say framework, I should say this is a content you should talk about. You should not go out of the scope where we need to regulate the information which were trained, which it got trained, and the way it is responding back. And I just want to say a simple, small, funny example here. For example, if I am using a Siri and if my wife just calls me, "Where are you?" If I say I am in my friend's location, then I can say Prakash, right? If suddenly then my wife says to Siri, "Where is my husband?" If it actually comes back with another location, which is a he's doing some party in somewhere location, like, so this is where, like, these are the social social restrictions in terms of NLP, because what exactly the series can do is they can just get the location where that mobile of his husband is located and just give that metadata to this and say this is where your husband is. So this is just a funny example where may things go wrong in terms of NLP, and how to regulate this framework and make usable and uh, without losing the security of the data, security of the people, and make the framework is where the most of the challenges now present in NLP area. And I've recently I also work for QML related NLPs, where and where exactly those things will fit in here is because um, when for example, if I given a question answer model where I will say I'm asking about a specific question, what is my what is the what is the market share of any company, right? If the data is not it's not available in my indexing database, if the model comes up with any other answer rather than which is incorrect, so how I can regulate that, how I can quantize those data. For example, they can be like in human beings, if you say something which we think, but what exactly we are referring to is a sarcasm, right? We can deal with sarcasm. How exactly model understands it's not exactly what we said, and doing we are saying it in a sarcasm way, right? So all these natures of language, how humans talk to each other, or humans actually write these blocks and all, is still yet to resolve in terms of NLP, and that can be worked also with QML options. But as of now, I don't have any specific thing to share related to the QML, but anyone can reach me out for further materials related to the QML side, right? So then mostly the takeaway from this session, I would say, is like uh, all the NLP solutions are still yet to is not ready for industrialization, where industries can just utilize in any basic apps. Only big companies are utilizing this information retrieval and all the stuff are already being done, other than the conversational layers and human like interventions and the translation engines. Even today the translation engine accuracy is 93%. There are some use cases for specific languages which they didn't even try, like they only refer as of now referring to around 93 languages which are available in the market. But when you take the whole globe, the number of languages are much more, right? Even in India, we have so many languages, Hindi, Telugu, based on the regions and all. Whether all these languages have been available in terms of NLP, I would say no, because they only taken the top 15, 10 languages which are mostly used in the industry markets. When even if I can say the problem which I face with Arabic, and when because the terms it actually writes from it's in different direction, right? To understand that kind of structure difference, for to make the data to train on top of it is still in question mark, because we don't have the core process, or even we have the core process, we need a right way to make it usable for the user. And before actually going through all this NLP stuff, actually how it's actually do, then the next, but things became very simple for us to utilize them. Anyone can just go to the Hugging Face models which are open source, and you can see an example there how we can just download it and how we can utilize in a present day-to-day languages, right? While choosing any model of all these things, the best thing you need to do is what exactly is your use case, whether this specific model will fit into your user data. There are so many challenges because each specific industry use cases are different from the open source models which they are got trained. So to train them back into, or to make them uh, utilizing your use cases, you need to do so many mathematical functions, techniques, and make it instead of using pre-trained, we need to modify the pre-trained structure and create your own base model. To create this own base model, the process is actually still it's a complex part. And I mean, other than that, even though we can see so many people are talking about NLP, this thing, chatbots, and language translations are getting utilized in the industry, in the market, but still, I can say they are not yet refined as good as computer vision. There is so much of scope in this area where all of you can learn and improve the existing structure and make to move to the forward, to take it forward.
Hmm. Thank you so much, Sai Praveen, for this amazing session. Yeah, NLP is a little tough, but you have made it a little easy because codes are a little easier when it comes to GPT, GPT-3, and all these. I think, yeah, we have to figure out ways in order to get the data input, data output, and yeah, no, guys, any doubts that you have, just drop it in the comment section. We'll be addressing right now. You can stop the share screen. Yeah, I know 11 people total watching at the end. Fine. But like, any people, any questions? So, yeah, I think it is a pretty basic intro for NLP, right? I think probably everybody got
Yeah,
an understanding of what this technology was. I think thank you so much, guys, for your valuable time and also for staying us live. And also make sure that you subscribe to this channel because this is a channel where we will be making sure that South India Summit, all the events that we will be doing, will be coming through to you. So don't miss out any of the events. Thank you so much, folks. Thank you.
yeah. Thank you.
Thank you. Bye, everybody.